Hello, welcome to the next section, News Topic Classification with Support Vector Machine. In this section, we will continue our journey of classifying text data, a great starting point of learning machine learning classification with broad real-life applications. We will be focusing on topic classification on the news data we used in Section 2, exploring the 20 newsgroups dataset with text analysis algorithms and using another powerful classifier, Support Vector Machine, to solve such problems. We will get into details for the term frequency inverse document frequency and Support Vector Machine, or SVM. We will also look at the mechanics of SVM and its implementations, multi-class classification strategies. We will then move on to explore about the nonlinear kernels of SVM, choosing between linear and Gaussian kernels, reducing overfitting in SVM. Lastly, we will learn about tuning with grid search and cross-validation. Now we move on to the first video of this section that deals with recap and inverse document frequency. In this video, we will learn how to use the tfidf approach to extract text features. Previously, we detected spam emails by applying naive Bayes classifier on the extracted feature space. The feature space was represented by term frequency, or TF, where a collection of text documents was converted to a matrix of term counts. It reflected how terms are distributed in each individual document, however, without all documents across the entire corpus. For example, some words generally occur more often in the language, while some rarely occur but convey important messages. Because of this, it is encouraged to adopt a more comprehensive approach to extract text features. The term frequency inverse document frequency, or tfidf, it assigns each term frequency a weighting factor that is inversely proportional to the document frequency, the fraction of documents containing this term. In practice, the IDF factor of a term T in documents D is calculated as in this equation, where ND is the total number of documents is the number of documents containing T, and the 1 is added to avoid division by 0. With the IDF factor incorporated, it diminishes the weight of common terms occurring frequently and emphasizes terms that rarely occur but are meaningful. We can test the effectiveness of tfidf on our existing spam email detection model by simply replacing the TF feature extractor, count vectorizer, with the tfidf feature extractor, tfidf vectorizer from scikit-learn. We will reuse most of the previous codes and only tune the naive Bayes smoothing term. Let's import the tfidf vectorizer. Next, initialize the smoothing factor option. Import the default dictionary. And now create the AUC record. We then add a for loop for different parameters and the smoothing factor. As you click Enter, you will see the multinomial function is executed for every alpha, the class prior and fit prior values, that is, for every smoothing factor. Now let's print the max feature smoothing fit prior AUC. Lastly, we print the records by using the for loop. As you click Enter, it returns the records in a tabular form. The best averaged tenfold AUC, 0.9943, is achieved, which outperforms 0.9856, obtained based on TF features. In this video, we learned the tfidf approach to extract text features.